Good morning all. Today we are going to discuss about chi-square distribution. Chi-square distribution, it provides a measure of correspondence between the theoretical frequencies and the observed frequencies. The formula for it is given by chi-square is equal to sigma OI minus EI the whole square divided by EI, where OI refers to the observed frequency, EI is the expected one. So degrees of freedom is given by n minus 1. This is the table for chi-square distribution. Here is degrees of freedom 1, 2, 3, etc. Up to 60 it has been given, and this is a 99% and 95%, 90%, 75%, like various percentages has been given. So this is the chi-square distribution table. We will be referring it, and here also usually the values of it will be given. Supposing if I want to refer to 9 degrees of freedom at this 95%, that is 3.325 like this, so it will be given. A die is thrown 264 times and the number appearing on the face X follows the following frequency distribution. That is, X is 1, 2, 3, 4, 6. That is a number appearing on the face of a die, and frequency of which how many times 1 appears is 40 times 1 appears. That is, out of 264, 40 times is 1 appearing, and 32 times 2 is appearing, 28 times 3 is appearing, and 58 times 4 is appearing, 54 times 5 is appearing, and 60 times 6 is appearing. Out of 264 times, these are the frequencies. Now calculate the value of chi-square. The frequencies in the given data are the observed frequencies. Assuming that the die is unbiased, the expected number of frequencies for the numbers 1 to 6 to appear on the face is mean of it. That is, 264 times we are throwing. Out of that, if we are dividing it by 6, 44 times each one should appear. That is, now the data is as follows. Number on the die is 1, 2, 3, 4, 5, 6. And the observed frequency as given in the data is 40, 32, 28, 58, 54 and 60. And the actually expected frequencies which we have calculated for each number is 44 everywhere. So we are supposed to get 44 times 1, 44 times 2, 44 times 3 and so on. But here what we are getting is 40, 32 and so on. This is the observed frequency. So in order to calculate the chi-square, the second row refers to the observed frequency, the third row refers to the expected frequency, and the formula for chi-square is given by summation OI minus EI the whole square divided by EI. That on calculation, that is 40 minus 44 by whole square by 44 plus 32 minus 44 whole square by 44 and so on. If we do, we get the value of chi-square as 22. Let us take another problem. 5 dice were thrown 96 times and the numbers 1, 2 or 3 appearing on the face of the dice follows the frequency distribution as below. Number on the dice showing 1, 2 or 3 is 5, 4, 3, 2, 1, 0. Frequency 7, 19, 35, 24, 8, 3. These are the frequencies. Here the question is, Test the hypothesis that the data follows a binomial distribution. And I have given in the chi-square distribution value 11.07 for 5 degrees of freedom. Here just to for the reference purpose I will show you the table. You can see here degrees of freedom is 5 and chi-square is at 5% level of significance, it is 11.07. 11.07, 5 degrees of freedom, 5% level of significance. Hope it's clear. Okay. The data gives the observed frequencies and we need to calculate the expected frequencies. The theoretical frequencies of getting 5, 4, 3, 2, 1, 0 successes with 5 dice are respectively the successive terms of the binomial expansion. They are respectively 96 into 1 divided by 2 power 5 or 96 into 5c1 into 1 divided by 2 power 5, 96 into 1 divided by 2 power 5, etc. That is 3, 15, 30, 15 and 3. So the observed frequencies, it is given as around 7, 19, 35, 24, 8 and 3. And the expected frequencies are 3, 15, 30, 30, 15 and then 3. So this has been calculated by using the binomial distribution formula, where the binomial distribution formula is NCR into P power R Q power n minus R. So when we use this one and here it is the 96 is multiplied because the 96 is the value number of times it has been done. So when we do that, we will be getting respectively 3, 15, 30 etc. Okay. So chi-square is given by OI minus EI the whole square divided by EI. So that gives us 16 by 3 plus 16 by 15 plus 25 by 30 plus 36 by 30 and 45 by 49 by 15 and 0 by 3. That gives us 11.7. Look at the difference, 11.7 here, but actually the chi-square value is 11.07 and here it is 11.7 or 70, which is greater than the chi-square value. So when it is greater than that, the hypothesis that the data follows a binomial distribution is rejected. That means it doesn't follow the binomial distribution. Next, let us see another problem for the Poisson distribution. Put a Poisson distribution for the following data and test the goodness of fit given chi-square at 5 degrees of 5 level, 5% of significance, 7.815 for 3 degrees of freedom. X is 0, 1, 2, 3, 4 and F is 122, 60, 15, 2, 1. So the value of mu is 0 because 0 into 122, 1 into 60, like this we will be doing. 0, 60, 30, 6, 4. You can refer here 6 and 4, 30, 60 and 0. all divided by 200. This 200 is obtained by adding all this 122, 60, 15, 22 and 1. So we are getting the mu value as 0.5, and we know that for the Poisson distribution mu is equals to m for this Poisson distribution, and the formula for the Poisson distribution is given by m power x e power minus m divided by x factorial. And since it is 200 is the total, f of x is 200 into p of x, or 200 into 0.5 power x e power minus 0.5 divided by x factorial, and e power minus 5 is given by 0.6065. Therefore, f of x is given by 121.3 into 0.5 power x divided by x factorial. So we can substitute the values of x as respectively 0, 1, 2, 3, 4 like that. So 0, f of 0 if you put, it will be 121, f of 1 is 61, f of 2 is 15, and f of 3 is 3, f of 4 is 0. If you want, one can be illustrated here. It is 121.3 into 0.5 power x. One 121.3 into 0.5 to the power of 1 divided by 1 factorial, because x is 1 here. So 121.3 into 5 if you do, we will be getting 61. Similarly, if we are putting it as 2 divided by 2 factorial, for this one 3 divided by 3 factorial, 4 divided by 4 factorial, and so on we need to do. And for this respectively we will be getting 121, 61 and so on. Now 122, for the expected value, the observed frequency is 122, means expected one is 121 and observed one is 60, and this is 61, 15 and 15. Here the last two values are added. Since the last of the expected frequency is 0, so we shall club it with the previous. Now the chi-square value, as the formula, when we calculate the chi-square value, we are getting it as 0.025, and which is lesser than 7.815. So the fitness is considered good. Thus the hypothesis is that the fitness is good, can be accepted. Thank you.